Picture this. You're standing at the base of the Great Pyramid of Giza, craning your neck to see the top of a structure that weighs 6.5 million tons. For over 4,000 years, this monument has defied explanation. How did ancient people, working with nothing but copper tools and human muscle, create something so impossibly massive and precise that we're still scratching our heads today? For centuries, wild theories have tried to explain pyramid construction. Aliens with advanced technology, lost civilizations with mysterious powers, ancient astronauts guiding primitive humans. But here's the truth emerging from archaeological detective work. The real story is far more fascinating than any science fiction. The ancient Egyptians were engineering geniuses who developed revolutionary construction techniques that we're only now beginning to understand. The Great Pyramid contains over 2 million stone blocks, each weighing between 2 and 15 tons. If you worked around the clock, placing one block every 2 minutes, it would take over 7 years just to stack them. Yet, the ancient Egyptians built the entire structure in roughly 20 years, working only during the 3-month flood season when farmers were available for construction work. How is that mathematically possible? The secret lies in something archaeologists call the internal ramp system. Recent discoveries using cosmic ray imaging and ground-penetrating radar have revealed that the Egyptians used an ingenious spiral ramp that corkscrewed up through the pyramid itself. Think of it like a parking garage ramp, but built into the structure as they constructed it upward. This internal ramp system solved the greatest logistical challenge: how to lift millions of tons of stone to heights of over 400 feet without modern machinery. But here's where it gets really mind-blowing. The pyramid blocks weren't carved from distant quarries and dragged across the desert by thousands of slaves, as Hollywood would have you believe. The latest geological analysis shows that most blocks were actually cast in place using limestone concrete. French scientist Joseph Davidovits proved that many pyramid stones contain tiny air bubbles and organic fibers that could only exist if the limestone was mixed with water and recast. Here's how it worked. Workers would crush local limestone into aggregate, mix it with water and natural binding agents like natron salt, then pour this concrete-like mixture into wooden molds right where each block needed to be. This explains why pyramid blocks fit together so perfectly that you can't slide a knife blade between them. They weren't carved to fit, they were cast to fit. The joints are so tight that capillary action draws moisture into the gaps, creating an almost vacuum-like seal. This casting technique solved multiple engineering problems at once. Instead of quarrying massive blocks and somehow lifting them hundreds of feet into the air, workers could carry lightweight raw materials up the ramps and create heavy blocks exactly where they needed them. A single worker could carry enough limestone aggregate up the ramp to create a 2-ton block at the destination. The Egyptians invented concrete 4,000 years before the Romans, who are usually credited with its development. But the Egyptians weren't just randomly stacking blocks. They were master mathematicians who understood principles of physics that we thought were discovered much later. The Great Pyramid's base is level to within just 2 centimeters across its entire 750-foot width. That's more precise than most modern construction. The foundation stones are cut so accurately that the total variation across the entire base is less than the thickness of your thumb. How did they achieve this without laser levels? The answer lies in their water-based leveling system. The Egyptians created a network of water-filled channels around the pyramid's base. Water always finds its own level, so by marking where the water surface touched measuring rods placed around the perimeter, they could create a perfectly level foundation. Brilliantly simple, yet incredibly effective. They even accounted for the curvature of the earth, adjusting their measurements for the slight variation in water level across the massive foundation. The precision doesn't stop there. The Great Pyramid is aligned to true north with an accuracy of just 3/60ths of a degree. That's more accurate than the Greenwich Observatory when it was first built. The Egyptians achieved this by using stellar observations, tracking the rising and setting points of specific stars over time to determine true north. They were astronomers as much as they were builders, understanding celestial mechanics with remarkable sophistication. Even more impressive, the pyramid's internal passages align precisely with specific stars and constellations that were significant in Egyptian religious beliefs. The so-called air shafts actually point directly at stars associated with the afterlife journey of the pharaoh. This wasn't accidental. It was deliberate stellar engineering that required generations of astronomical observation and mathematical calculation. Now let's talk about the workforce. Forget everything you've seen in movies about whip-wielding overseers and suffering slaves. Recent excavations of worker villages near the pyramids reveal a very different picture. These were skilled craftsmen who were well-fed, received medical care, and were organized into competing crews with names like Friends of Khufu and Drunkards of Menkaure. The workers lived in purpose-built villages with bakeries, breweries, and medical facilities. Animal bone analysis shows they ate meat regularly, including prime cuts of beef, which was expensive even then. Workers consumed an estimated 4,000 calories per day, more than modern construction workers. Skeletal remains reveal that injured workers received sophisticated medical treatment, including brain surgery, bone setting, and even dental work. This wasn't slave labor. It was a highly organized operation employing Egypt's best craftsmen. Archaeological evidence suggests these workers took immense pride in their craft. Graffiti found inside the pyramids includes boastful messages from work crews competing to outdo each other. Messages like the Vigorous Gang and Boat Gang of Khufu show workers identified strongly with their teams. These aren't the messages of oppressed slaves, but of motivated professionals competing for recognition and bonuses. Modern engineering estimates suggest that the Great Pyramid required a permanent workforce of about 2,000 skilled craftsmen, supplemented by up to 8,000 seasonal workers during the annual flood season. That's far fewer people than the 100,000 workers described by ancient Greek historians who visited Egypt centuries later and relied on exaggerated local legends. The key to managing this workforce was the Egyptians' sophisticated understanding of mechanical advantage. They used a combination of levers, rollers, and pulleys to move massive stones with surprisingly small teams. Recent experiments have shown that a team of just 20 workers can move a 15-ton block using wooden levers and rolling logs. The Egyptians turned physics into their workforce multiplier, understanding leverage ratios and mechanical advantage centuries before these principles were formally documented. One of the most ingenious aspects was the use of counterweight systems. As blocks were raised up the internal ramp system, empty sleds would descend the same ramps, using gravity to help pull the loaded sleds upward. It's the same principle used in modern cable car systems, except the Egyptians figured it out 4,500 years ago. They even used water-filled containers as adjustable counterweights, fine-tuning the system for different block sizes. The timeline of construction reveals another stroke of genius. The Egyptians didn't build pyramids linearly from bottom to top. They worked in phases, completing the internal chambers and passages first, then building the pyramid structure around them. This explains why the internal chambers are so precisely aligned, even though they're buried deep inside millions of tons of stone. The king's chamber, for instance, was built and finished before the pyramid reached that level, then carefully incorporated into the growing structure. The tools they used were surprisingly sophisticated, despite being made from copper, wood, and stone. Copper saws with abrasive sand could cut through limestone efficiently, creating cuts smoother than many modern techniques. Wooden rockers allowed small teams to move massive blocks with minimal effort. They even developed specialized tools for specific tasks, like copper tubes used to core drill granite blocks with precision that rivals modern equipment. Perhaps most remarkably, the Egyptians understood quality control in ways that wouldn't be out of place in a modern factory. Each work crew had its own mark or signature that they carved into blocks, creating an ancient version of quality assurance tracking. When archaeologists find substandard work, they can trace it back to specific crews and time periods. This accountability system ensured consistent quality across decades of construction. The logistics of supplying the construction site were equally impressive. Teams of workers quarried limestone from nearby sources, transported granite from Aswan over 500 miles away, and managed the flow of materials to ensure construction never stopped. They built harbors, canals, and roads specifically to support pyramid construction, creating infrastructure that served Egypt for centuries. The legacy of pyramid construction extended far beyond the monuments themselves. The engineering techniques developed for pyramid building influenced Egyptian architecture for thousands of years. The mathematical principles they mastered laid groundwork for geometry and engineering. The organizational methods they pioneered influenced how large construction projects were managed throughout the ancient world. Recent archaeological discoveries continue to revolutionize our understanding. Ground-penetrating radar has revealed previously unknown chambers and voids within the Great Pyramid. Computer modeling has confirmed that the internal ramp theory is not only possible, but actually necessary for the construction timeline. Chemical analysis of mortar samples has revealed the exact techniques used to mix and apply limestone concrete. What makes the pyramid builders' achievement even more impressive is that they accomplished it during Egypt's very first attempt at large-scale stone construction. The Step Pyramid of Djoser, built just a few decades before, shows clear signs of trial and error. By the time they started on the Great Pyramid, they had refined their techniques to near perfection. So the next time you see the pyramids, whether in person or in photographs, remember that you're looking at humanity's first skyscrapers, built by master engineers who solved complex problems with ingenious solutions. They didn't need aliens or lost technology. They had something far more powerful: human intelligence, determination, and the willingness to innovate. The pyramids aren't just monuments to dead pharaohs. They're monuments to human capability and the power of engineering to transform ambitious dreams into eternal reality.